Hello everyone, in this video let's discuss about SR latch using NAND gate concept. So if you are new to our channel, please subscribe for more engineering related topics. So to construct the SR latch using NAND gate, first let's know what is NAND gate. So this NAND gate is the combination of AND gate with NOT gate. So we can represent AND gate like this, similar to D, and if we put NOT in front of it, it will be NAND gate. What NAND gate will do means the output of the AND gate, will be complemented using the NOT gate. The output of AND gate will be complemented using NOT gate, and this whole process will be done by this circuit called as NAND gate. So now let's discuss about the truth table of NAND gate. So we will be having two inputs. Let's consider it as A and B and output as Y. Since there are two inputs, the combinations will be 0, 0, 0, 1, 1, 0 and 1, 1. Now if both the inputs are 0, that is, let's design the AND gate first and then complement the value, then we will get the NAND gate. So what will be the AND gate? For the AND gate, formula is A into B. So 0 into 0, it is 0, 0 into 1 is 0, 1 into 0 is 0, 1 into 1 is 1. So if both the inputs are high, the output will be high. Otherwise, in all the situation, the output will be low. Low means 0, high means 1. So this is of the AND gate. What NOT gate does? NOT gate will complement the value. That is 0 will become 1 and 1 will become 0. So this is the NAND gate concept, AB bar. So this became the truth table of the NAND gate. Now using this truth table of the NAND gate, we can come to a conclusion that if in input side, that is within these two inputs, if we have at least one zero, then the output will be equal to 1. At least 1 0, output will be equal to 1. See, 0 0, 2 0, output is 1. 0 1, 1 0, output is 1. 1 0, 1 0 is there, so output is 1. 1 1, there is no 0, so the output will be 0, like that. If in input side at least 1 0 is present, means then the output will be equal to 1. So using this concept, let's design the SR latch. So we are using the NAND gate. So I showed the representation of NAND gate. So this will be Q and Q bar, because all the latches will be having two outputs. So both will be complement of each other. If Q value is equal to 0, Q bar value will be equal to 1. If Q value is equal to 1, Q bar value will be equal to 0. Therefore, we can say that only complementary output will be allowed in the latches. Now we gave one input. Now this output will act as input to this NAND gate, and this NAND gate's output will act as the input to this NAND gate. And what are the two inputs? S and R. Now let's design the truth table for SR latch using NAND gate. So S and R will be the input and the output are Q and Q bar. So since we have the two inputs, the combination will be 0 0, 0 1, 1 0 and 1 1. Now let's consider the conditions one by one. If I consider the condition, that is 0 and 1, S value is 0 and R value is 1. I already said if in input side at least 1 0 is there, means output will be 1. At least 1 0 is there, so the output will be 1. Next, this output will act as an input right here. So 1 and 1. If both 1, output will be 0. So the two outputs Q and Q bar are complement to each other. That is, Q value is 1 and Q bar value is 0. So 1 and 0. Next, let's consider 1 and 0. That is, S value is 1, R value is 0. So I said if in input side 0 is there, means output will be 1. So this will become 1 and this will be given as the input right here. 1 and 1. If two ones are the input, output will be 0. Now you see Q value is 0 and Q bar value is 1. Both are complement to each other. Complement means opposite. So we can write 0 and 1. Now let's consider the case that is 1 and 1. If both S value is equal to 1, R value is equal to 1. If both values are equal to 1, the output will be 0. So let's consider this as 0. Since this output will act as an input right here. Therefore 1 and 0. At least 1 0 in the input, the output will be equal to 1. Now you can see 0 and 1. So Q value is 0, Q bar value is 1. Q value is 0, Q bar value is 1. So therefore this output is already in the memory. So we can write in memory. We don't need to repeatedly write 0 1. We can write it is in the memory. Now if I consider the input 0 0. So S value is 0, R value is 0. If both are zeros, the output will be equal to 1. So let's consider the output, this output as 1. If I give this output as input right here, so 0 and 1 will be my inputs, 0 and 1. So in the input side, if the at least 1 0 is there, output will be 1. So this value will be equal to 1. So Q value is equal to 1, Q bar value will be also equal to 1. So this is not allowed. Only complementary outputs are allowed. So I can say this invalid. Using NAND gate, if we draw the SR latch, the inputs 0 0 will be invalid. If I use the NOR gate, 1 1 will be invalid. So the video of the SR latch construction using a NOR gate, link is given in the description. You can access. Hope you understood the concept of SR latch design using NAND gate. If you like the video, please subscribe for more engineering related topics. Thank you.